Hey there, what's good guys? So today I'm going to look at the Pythagoras theorem and why it works, because you might think like, Pythagoras theorem, that kind of seems out of nowhere. I don't even know like if that works, you know, or like why it works. So Pythagoras theorem, if you recall, is a squared plus b squared equals c squared. Alright, so that's the formula. So let's get started with the proof. So, say we have a triangle here, right? We're gonna make it like that long. I don't know, like this. That's not quite what I wanted, but it'll work. So say we have this triangle, right? A right triangle. And the Pythagoras theorem, if you remember, only works for right triangles. So let's say this small side right here, we're gonna call this A. This long side, we're gonna call this B, blue B, red A. And the hypotenuse, or the side opposite of the right angle, we're gonna make it green and call it C. Now we're gonna make this whole triangle not completely colored in. Too lazy. I'm going to highlight it in yellow. So we have this yellow triangle with sides A, B, and C in order of shortest longest. So, say we take this triangle, right, and we make 4 of them, and then we arrange them into this shape here, right? So if you'll notice, it's in the shape of what looks to be a square. Maybe it's not. Let's see. So let's start out actually. What if we wanted to find the area of these 2 squares, or these 2 boxes, right? These 2 white boxes. So let's start with this one. If we recall, right here, this short side, we called this A. And these are the same triangle since we just duplicated them over. So this small side is A, and this small side of this triangle is also A. And so if we want to find the area of this square, we take length times width, or these 2, and since they're both A, take A times A, which is A squared. Now, what about this box? Well, if we look again, we called the long side B. Made it a blue B. So, length of these 2 sides, so it works B and B. So length times width, B times B, which is B squared. Alright, so we have the area of these 2 boxes. Now say we wanted to find the area of this entire orange box, right? So what we'd want to do again is length times width. So this side right here, this is part of another triangle here with the long side, which is B. And then this is A, right? From, if we look across from this triangle. So that's B, that's A. And if we look here, this is a short side. That would be A and B again, right? So that's B. And then these are A's. So now we want to do length times width. So these seem to be the same length since it's A plus B for both sides, right? So what we'd have to do is take A, take the A's, right? Add the B's, and it would look something like this, right? So we could simplify this, but for our sake, we're gonna leave it in squared form, or I don't know. We're just gonna leave it as squared. Right, so the area of this whole orange square, I'm gonna pretend this is the whole orange square. This represents the whole orange square. The area of the whole orange square equals A plus B squared. Alright, so we have this. So now let's say we took these triangles and rearranged them into these same four triangles and rearranged them into a new shape. making this, right? Alright, so let's do the same thing as we did before, and we're going to try to find the area of this white space, this white box. So, if we look again at our sheet here, the hypotenuse, or the side opposite of the right angle, is C in green. So, here's the right angle across from it, the hypotenuse. So the side length of this is C. And again, let's do this one. Across this right angle is another side. Let's make it green, call it C. So if we want to find the area of this square right here, we're going to take length times width, or C times C, which is C squared. Alright, now let's find the area of the big orange square again, right? So if we notice here, we have a short side, which we called A, another short side, A, and then a long side here, which is B, another long side here, which is B. So in order to find the area of the large orange box, we'd take length times width, or A plus B, and A plus B times each other. So if we notice, that's the same thing as right here, right? So then this simplifies to A plus B squared. So again, to tell the difference, let's put a 1 here for this one, 2 there, equals A plus B squared. Alright, so now we have the areas of this square, this square, this square, and these two orange big squares, right? So with this reasoning, right, we know that if we look at this, right, this square 1 has the area of A plus B squared. Square 2 has the area of A plus B squared. So therefore we can take from that these two squares have the same area, right? So they are equal, right? So now, if we remember, we kind of made these shapes using these 4 yellow triangles, right? So if we take those yellow triangles, right, we take the square, we have this square here, we're going to use this as a second square, right? First square, second square. If we take back out the 4 yellow triangles, right? Okay, sorry, there's a bit of a cut there. But, so we take these 2 orange squares, and we subtract the, that's not a right triangle. At the point though, if we subtract the 4 yellow triangles from the orange squares, so if we called this the first one, right, and the second one, so this first one, when we take out these 4 yellow triangles, we see we have A squared and B squared, right? So, the area of the first square minus 4 yellow triangles is A squared plus B squared, right? So we have this one triangle, take out 4 yellow triangles, we have A squared plus B squared. Alright, so now the second orange square, right, we have this. And if we take out these 4 yellow triangles, get rid of these, we're left with C squared. Alright, so now what can we do with this? So, if we know that these 2 squares are the same, right, and we took 4 yellow triangles out of each of them, then we know that these 2 answers must be equal to each other. So therefore, we can say that A squared plus B squared equals C squared. And that is where Pythagoras' theorem comes from. So yeah, it's a pretty neat trick I learned. I'm gonna look up the guy's name actually, who I was inspired to do this video. Yeah, it's kind of cool. It's kind of nice to know where like the formula comes from. Not much use, I suppose, when you're using the formula itself, but yeah, I think his name was Eddie Wu. Yeah, Eddie Wu. Yep, Eddie Wu. So yeah, if you want to check out his channel, I suppose there's some pretty neat stuff in there, like that. So yeah, thanks for watching.